Welcome to Mr. Chalk's Revision Tips. In this video, we will look at specific heat capacity, calculating specific heat capacity, and the required practical involving specific heat capacity. The specific heat capacity of a material is the energy required to raise 1 kilogram of that material by 1 degree. The specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. So this means that it takes 4,200 joules to raise the temperature of 1 kilogram of water by 1 degree. So if heat is absorbed by 1 kilogram block of lead, the particles gain energy. So since lead is a solid, the particles are only vibrating. They vibrate faster after being heated. As particles are close together in a solid, they are more likely to heat each other and pass the energy around. So this means that the energy spreads through the block quickly and the temperature of the block goes up quickly. It takes less energy to raise the temperature of a 1 kilogram lead block by 1 degree than it does water. So the equation for specific heat capacity is the mass times specific heat capacity times by temperature change is the energy. So if we rearrange that to get specific heat capacity, it's going to be energy divided by mass times temperature change would be our specific heat capacity. So if we look at this example, so a metal worker quenches a steel rod by heating it to a temperature of 900 degrees before placing it into cold water. The mass of the steel rod is 20 kilograms. The final temperature of the rod and the water is 50 degrees. Calculate the energy transferred to the steel rod. Right, well, we're going to go and use our equation for changing thermal energy, which is going to be mass times specific heat capacity times by temperature change, which would be 20 times 420 times by 850, which would give us 4,080,000 joules. So in the second example, so before the 25 kilogram of water begins to boil, it needs to be heated from 20 degrees C up to 100. If the specific heat capacity of water is 4,180 joules per kilogram, how much thermal energy is needed to boil the water? Well, we would go and put all of those variables into the equation, which would give 0.25 times by the specific heat capacity times by the temperature change, which would give us an answer of 83,600 joules. So finally, if we look at the required practical and how that's set up to look at specific heat capacity, to start off with, we would measure and record the mass of a copper block in kilograms if we were looking at copper. We'll place a heater into a larger hole in the block. Would connect an ammeter, a power pack and a heater in series. You'd connect a voltmeter across the power pack. You would then use a pipette in a small amount of water into the hole. Into the second hole, you'd go and place a thermometer. You would switch on the 12-volt power pack. You'd record the readings on the ammeter and voltmeter, so these technically shouldn't change during the experiment. Measure temperature and start the stop clock. Then you would record the temperature for every 10 minutes. Thanks for watching.